Hello guys, welcome to my YouTube channel, and today we are going to understand not this, yeah, this. So basically we are going to understand the decision tree concepts or the important concepts like information gain and entropy. Okay, so before going ahead, let's understand what the decision tree is. Okay, so a decision tree is a popular machine learning algorithm used for both classification and regression tasks. So we are going to calculate the entropy here using the classification and regression tasks. Okay, not regression, just the classification. Okay, so it models decision based on a tree-like structure where each internal node represents a decision or test on a specific feature. Okay, let's not go into deep with this. So how decision tree works is basically on entropy and information gain. Okay, like how the values are predicted here. So we are going to use a classification model here. So basically what the classification suggests here, so basically you have two kind of things like binary classification. In case of binary classification, we have yes and no, true or false, play, don't play, etc. Okay, there can be also multi-class classification. Okay, so we are not going to do that here. So this is the binary classification problem. So let's have a look into this. Okay, and regression is nothing but the continuous values like predicting the salary, etc. Okay, or the household price, etc. Okay, so this is the classification problem, and here information gain is used and entropy is used to basically calculate the root node. Okay, so let's understand what the root node and everything is. Okay, so basically so before that, let's understand what is information gain. So information gain is a measure used to evaluate the effectiveness of a feature in reducing uncertainty or entropy in a dataset. So basically in short, information gain is nothing but the higher the information gain in the dataset, that feature you choose as the root node. Okay, and entropy gives us the impurity or the disorder in a dataset. For example, here you can see that suppose if you consider this column outlook. Okay, here you have a column in which there is sunny and overcast and rain. Now this suggests us the disorder or the impurity after calculating. That means how many sunny are present against the target class and how many overcast is present against the target class and how many rain is present against the target class. So basically if the entropy of sunny, overcast and rain is like unreliable, not able to calculate, or higher you can say of this column, then you cannot predict the class in a good manner. And if the entropy is 0, you can directly suggest that like the impurity is low, and you can like suggest that the data is homogeneous and you can easily predict the target variable. Okay, so to understand this entropy, I have one example here. Okay, so you will understand it in a better way. Okay, so here we are calculating, and the formula for entropy is h of x pi log of pi and qi log of qi. Okay, here pi and qi is like success event and failure event here. Okay, that is pi is probability of y, that is 1, and probability of success event, and probability of y, that is 0, that is failure event. Okay, so this is how you calculate entropy. Now here they have taken the example case 1, that is coffee flavor, quantity of pouches and the probability. So here you can see caramel latte is there are total quantity is 7 and cappuccino is 3 and total are 10. Now to calculate entropy, how do you calculate entropy of caramel latte? It is 0.70, that is this log of 0.70 and 0.30 and a log of 30, so it is 0.88. Now the entropy is higher here. That what does this suggest? So this is the measurement of uncertainty when given box full of coffee pouches and asked to pull out one of the pouches when there are 7 pouches of caramel latte flavor and 3 pouches of cappuccino flavor. Okay, so this is the entropy. That means you cannot decide like what you, if you pick one of the pouches, what is what. Okay, clearly that is what it says, that is impurity is more here. Okay, now case 2, here there were 7 and 3, now here there are totally 5 and 5. Now if the quantity of products is same, here you can see that entropy is 1 here. Okay, that means totally high, you cannot predict it. Okay, that what pouch you are picking, it has like plus 5, like half the probability. Okay, it can be either caramel or cappuccino. Okay, now in case 3, you can see that caramel latte is 10 and cappuccino is 0. Okay, now here you can see that entropy is 0 directly. That means here you can see in scenario 3, when we have only one flavor of coffee pouch, that is this, okay, caramel latte, and have removed all the pouches of cappuccino. Okay, then the uncertainty or the surprise is also completely removed, and the aforementioned entropy is 0. So we can then conclude that information is 100% present. That means you can say that whatever you are picking is caramel latte here, that is information is 100% present, like that. Okay, so this is how entropy gives us like what to predict. So if there is entropy of equal number of things, then you cannot go ahead like that. Okay, and here you can go ahead with couple of things here and there, like you can go and subdivide other features also. Okay, so with this, let's go to our example. Let's not make it confusing here. So here you will understand it beautifully. Okay, don't worry about that. So I have like 4 columns here: outlook, temperature, humidity, and windy. Okay, and class is our target variable, so it gives us like whether you can play or not play. Okay, so you can consider any sport like soccer, football. Oh yeah, basically both are same or not, I don't know. Okay, football or cricket you can say. Okay, and here you can see in outlook there are subclasses, like it is the weather is sunny, overcast, and rain. Okay, and temperature is 75, 80, it is ranging from 65. So let's consider temperature threshold as below 75 and great, above 75. Okay, and humidity also same, like below 75, above 75. And windy is like true in the sense strong wind, and false in the sense not that windy. Okay, so with this let's go ahead. Okay, so how the target variable is achieved in case of, or how the decision tree starts to divide, okay, the root node, or how does it choose the root node here. Okay, so first here you can see at the root node for a decision tree, what is the information gain. So basically what we do is we first of all calculate the entropy of this class. Okay, that means total of subset, like the target variable you can consider. Okay, so how you can calculate the entropy here. So p plus log of p plus, that is positive events, that is play. Okay, there are 9 total, I think. Yeah, 9 positive and 5 negative. Okay, so minus of positive events and log of positive events, minus of negative events, log of negative events, or the target variable. So 9 are positive, so total are play occurs 9 times and don't play occurs 5 times. Okay, so this is how you calculate the entropy. So 9 by 14 log 2 of 9 by 14 minus 5 by 14 log 2 of 5 by 14. So it comes out to be 0.94. Okay, so this is the entropy of entire data set you can consider. Okay, so next step is you need to calculate the entropy of this outlook column. Like each column we can calculate the entropy. Okay, so let's calculate the entropy of every column here. Now if you want to calculate the entropy of every column, you need to calculate the entropy of sub values available there. Okay, so here we can see we are calculating entropy of sunny, and then entropy of overcast. Okay, and entropy of rain here. So similarly entropy of sunny is calculated like 2 by 5 log 2 of 2 by 5 and 3 by 5 log 2 of 3 by 5. So why it is 2 by 5 and 3 by 5? So because total there are 5 sunny cases. Okay, that is why in the denominator it is 5, and in the numerator it is 2 times sunny, that is 2 times it is positive, and 3 times it is negative, that is don't play. Okay, that is why 2 by 5 and 3 by 5. Okay, so this way you get the sunny, and the similar way you get it for overcast. So in case of overcast, you can see that it is 4 by 4 and here it is 0 by 4. Okay, so why it is like that? So basically in overcast all the target variables are play. Okay, that is why the entropy is 0 for other case. Okay, so for overcast it is 0. Okay, entropy, that is impurity, is 0, or uncertainty is 0. Okay, and in case of rain it is 0.97. Okay, so now how you calculate, this is how you calculate entropy. Okay, and now to calculate information gain, what you do is you take the entropy of entire data set minus summation of S of V, that is this subset. Okay, like occurrence of this 4 sunny, 5 rain, 4 outlook, 5 rain and 5 sunny, right, yeah, 5 sunny, 4 overcast and 5 rain, okay, not outlook, overcast, okay. So those are the things, and out of total values, that is 14, okay, like that. And you need to give the entropy of each. So we have calculated entropy of sunny as 0.97, and this is 0, overcast is 0, and rain is 0.97 again. So entropy of entire subset, that is 0.94, which calculated in the beginning here. So this one 0.94 minus 5/14 of sunny into entropy of sunny, and 4/14 into entropy of overcast, yeah, and 5/14 into entropy of rain, okay. So it gives us information gain of 0.2464, okay. So similarly, in similar scenario, we calculate the entropy of humidity and information gain of humidity and information gain of wind and information gain of, I think, temperature, yeah, information gain of temperature, okay, and then information gain of wind. So when you get the information gain of all the 4 features, you will find that information gain of outlook is highest, okay. So this is the root node basically. So what happens here is we select outlook as the root node since the information gain is higher here, and based upon that we start plotting the decision tree. So here you can see, okay, so it is tilted. So here you can see outlook, it is 9 plus 5, that is total occurrences, 9 positive, 5 negative. Outlook is selected as root node here. Now outlook is subdivided into sunny, overcast and rain here, okay. Now you can see that for sunny we have selected humidity. Why? Because in case of sunny, you will see that we have selected temperature, humidity, wind and class. So if we go above here, we delete the outlook column and we take the occurrences of sunny. So for sunny it is 75 till 69, humidity is 72, 70, wind is from here to here, and like you can select from here till here, not here, till here. We select this as a sub data set, you can consider that, okay. And for this sub data set, you do the same process what we did for the whole data set. You are getting it, right? So if I go here, you can see that we have calculated the entropy of entire data against this target, and then entropy of temperature greater than 75, less than 75, and information gain, then entropy of humidity and Ig gain of humidity, and for wind, okay. And you can see that root node is humidity here, that means Ig of humidity is more here, okay. So if you go here, you can see that humidity is selected as root node of the child here of, okay. So this is parent and this is child, so humidity is selected as root node in this second scenario. Now how do you select don't play and play here, okay. So this is again subdivided, but here you can see the best example, overcast. If you go at the overcast, not here, okay, not here, here. So if you go at the overcast of the tree, you can see that overcast gives us all the definitions as the target variable to play itself, okay. So we can directly predict that we can play. If the outlook is overcast, you can directly say that it is play. That means you can play, or you can predict the output as play, okay. Now in case of humidity, we try to find out this humidity, okay. So for humidity, you can see that we are directly selecting for greater than 75 don't play and less than 75 play. Why? So let's go to data here, and you can see that for humidity, let's go to temperature. So if it is 70, it is play. If it is 90, so it is greater than 75, it is don't play. It is 85, 95, don't play. Now 70, it is less than 75, it is play, okay. And okay, in case of sunny, okay, now you can consider that this. So basically for sunny, you can see that For sunny it is don't play and play. So we need to consider what we need to consider here. So only sunny, and then humidity greater than 75 is don't play and less than 70 is play. Okay, so this is how it is selecting at the child nodes or the predicting output. Okay, similarly for rain it is choosing and windy depending upon the information gain, and then true or false, then don't play. Okay, so if we go to rain here, where it is rain, okay, here, and you go to windy. Okay, so if it is true it is don't play, and if it is false it is play. Okay, so if again here if it is what you can say, there are subdivision, then again we need to choose a sub data set and again follow the same process. So this internally works like this, like it gets goes on dividing till the end node or the depth you can say, and then you can predict the output. Okay, so this is how your decision tree works. Okay, and this is for classification model guys, not for regression. Okay, for regression there is something called as Gini impurity. Okay, Gini impurity or Gini index. Okay, so that we need to look into. Okay, so this is how you calculate the entropy and information gain, and based upon that you can predict the values of the target variable. Okay, so hope this was a bit understandable in case of decision tree. Like decision tree is basically, okay, at the end of the video nobody will watch this I think, but yeah, decision tree is basically a supervised machine learning algorithm both for classification and regression models. It is working. Okay, and it particularly for classification models it takes in consideration of information gain and entropy. So entropy is the base here, and after that we calculate information gain to choose the root node from which the splitting starts. So this is the root node, and then these are the branches, different branches, and finally we predict the output variable depending upon the sub information gain and sub entropy. Okay, so this was pretty much explainer video regarding how decision tree works in case of classification model. So hope this helps guys. So do watch this. I will attach the data set in the description if you want. Okay, and if you find this video interesting or if you learn something from this video, do hit the subscribe button. Until then, take care. Bye bye.